Okay, hopefully this movie will be fairly simple, but it's an important concept that we're going to use a lot in our force problems, and it's called resolving or finding a resolution of forces. So in this case, we're going to take one single force. Most of the time we've been adding forces together to get a resultant, but let's say I just give you a resultant, and we'll take a force. Um, let's draw a grid here. We'll take any grid. And let's say we take a force that's 10 newtons, and it's at 127 degrees. So here's 90, and then that would mean we'd come down here like at 37. So we're going to have here's our vector, and this is 10 newtons, and this was 37 degrees. So here's our single vector that we have described in space, and if that's 37 degrees, we can figure out this other angle here too. It would be 53 degrees. And we want to resolve this. And what resolving means is that we're going to resolve it into its horizontal and vertical components, its x and its y's, or sometimes we've been looking at I hats and j hats. Either way you want to look at it. We want to resolve this into perpendicular components. So that's always important. We're going to do a lot of this whenever we have vectors that are at angles and we want to kind of put them into perpendiculars and horizontals. We're going to have to do this a lot. So it's going to be nice if we can do this quickly. So if I can take this vector and I can say that this vector, I can either go down and over, or I could go over and down. It's not going to matter which way you're going to do it. It's just you're going to use a different angle depending. So let's say I'm going to start here and I'm going to go, okay, this green vector is an over vector and it's a down vector. And I'll draw in the heads of those vectors there. It's an over to the right and a down vector, or I could have done a down vector and over to the right vector. So if I want to figure out this side, this is the x, and this side over here is the y, or this is my I hat, and this is my j hat. And the quick way to do this is always just as long as you're going to know your resultant. And if it's the opposite side you're trying to figure out, it's going to be sine. We're going to use the sine of the angle. So if I have, this is the opposite side I'm trying to figure out, I'm going to take the sine of 37 equals opposite, which is y, over the hypotenuse, which is 10. And then I'm going to take 10 times the sine of 37 equals y. But what I want us to do is get really quick at just realizing, okay, if I'm resolving vectors, just go to the opposite side of the angle and know that this is going to be the hypotenuse times the sine of the angle. What will this one be? Well, this is the adjacent side. So this is going to equal the hypotenuse times the cosine of the angle. So the opposite side, when we're resolving vectors, is always going to be the opposite side. This j hat here is going to be sine, or the hypotenuse times the sine of the angle. And this one here will be the hypotenuse times the cosine of the angle. Now I could have done it over here. I could have said, okay, let's go down and over this way. Well, what's this side going to be? Well, it's the opposite side. So this is going to be the hypotenuse sine of 53. And what's this side going to be? Well, it's the adjacent side. So this will be the hypotenuse cosine of 53. So if you're trying to find the adjacent side, it's going to be the hypotenuse cosine. If you're finding the opposite side, it's going to be the hypotenuse sine. And then we can calculate these out and see what they actually are numerically. But I want to be able to just take any single vector that we have and be able to resolve it very quickly. So just out of a quick review again, let's say we had a vector that, oops, that's just not very good at all. Let's say we have a vector that comes up like this. And let's say that the angle right in here is 10 degrees. 10 degrees. Okay, and this hypotenuse here is 20 newtons. 20 newtons. Okay, so I want to resolve this. Well, it's going to be a vector that goes over this way, and then a vector that goes up this way. And I'll draw the heads of those vectors on. I think we should always draw those on. And so if I want to figure out what they are, well, this side, what's this side? Well, it's the opposite to the angle, so it's going to be hypotenuse sine of the angle. Here's the adjacent side. What's this going to be? It's going to be the hypotenuse cosine of the angle. And it's just that easy. We do that every single time. The opposite side is going to be the hypotenuse sine, and the adjacent side will be the hypotenuse cosine. And hopefully you can see how to resolve vectors quickly.